Okay, so this is topic 3 notes, day 8. We're going to do domain, range, maximums, and minimums. Now, we've done these to a certain degree in the past, but not pulling them all together like what we're going to be doing today. Okay, so first thing, let's review what the domain is. So write down domain is the set of all x values. That's your domain, the set of all x values. Okay, the range is the set of all y values. So what you have to do is separate your thinking into just looking at the x's and then just looking at the y's. Your temptation is going to be to follow the curve. Like your eyeballs will do this. It'll follow this curve. And that's going to mess you up. You got to look in terms of x's, which go this way, and y's, which go this way. If it helps to use a pen to point to them so you know when they start and if they stop, do that. Okay, so let's start with domain. Usually I look for like the lowest x value possible. So these are x values, and the lowest x value possible is at -10, but it has an open point. An open point is the fence you don't own. It's like if most of you live in a house that has a fence. The fence borders you and your neighbor. In fact, either your neighbor paid for it and owned the fence, or you paid for it and you own the fence. Either way, though, the fence is a boundary marker between the properties. The open point is the fence you don't own. Your property gets infinitely close to it, but the fence itself is not yours. So this gets infinitely close to -10, but -10 is not part of it. Okay, so then my x values go to the side, and the last x value I have with a filled in point is right there. So my x values go from -10 to -6. That is your domain. So when you have a boundary on the left and a boundary on the right, the x goes in the middle, and it's going to be less than or equal to -6. It gets the bar because -6 does have a filled in point. -6 is the fence that you own. That fence is part of the domain. Now, on the other side, it's going to be greater than, but since it's an open point, there's no bar. It just gets really close to -10 without ever being -10. So that's your domain. X is greater than -10 and less than or equal to -6. Okay, now we're going to switch brain gears and we're going to go to range. So starting from the bottom, I'm looking for the lowest y value. Here is the lowest y value. It's right here at 1, and it has a filled in point. Now I'm still looking at y values. It goes up, up, up until it reaches here with an open point at 3. So my y values are between 1 and 3. Okay, so to write this as the range, the y goes in the middle. Now in this case, it's less than 3, but not equal to 3. So it gets a less than arrow and a 3, but no bar. Now on the other end, it's greater than or equal to a 1, and it gets the bar because 1 is included. It's part of the range. So that is your range. Okay, so, and we've done a little bit with maximum and minimum before, but it's just been a while. So over here, let's just remind ourselves what this is. Okay, the maximum is the highest y value. You can think of it as the tallest place on the graph. All right, the minimum of a graph is the lowest y value, and it is the shortest place on the graph. Now, when we do maximums and minimums, there is a certain format that we follow. You have to say what the max or the min is, and then where it happens. So it's going to be y equals something, either a max or a min, depending on what you're doing. And then you use the word at, and then x equals, what's the location? Where does that actually occur? Now, this graph, like all graphs, has its own specific trickiness to it. The highest y value should be the 3, except the 3 is an open point. So that means it never quite reaches 3. 2.9, 2.99, 2.999, 2.99999, and it keeps getting infinitely closer, but it never actually reaches 3, which means it doesn't have a maximum. If it never reaches a maximum point, then it doesn't have a maximum. Okay, now let's look at minimum. What is the lowest y value? Well, look at the range here. The lowest y value is a 1. So we do have a lowest value. So here's our minimum. Y equals 1 at, and this is where you're going to give the location. That 1 occurs right here, and it occurs with a -6 in the x position. So at x equals -6 is where it happens. So we did have a minimum, we just didn't have a maximum. All right, let's move on to another graph. Okay, so on this graph, this is a parabola. We're going to find our lowest x value. So here we are, nothing, 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 boom, we have an arrow. So that arrow keeps going to the left, which means we have an arrow for the domain. It just keeps going to the left. So now I'm following the graph. We go to the right, 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 and boom, another arrow. So my domain doesn't have any restrictions. It never stops. It's everything. So when it's everything, the domain is all real numbers. And if you remember how to use that symbolically, it's x is an element of, so a small c looking thing with a straight line in it. That's an epsilon. And then real numbers is a capital R with a bar on it. So you can write out all real numbers, or you can write x is an element of the reals, which is shorter and a little bit more fun to write. Okay, now we're going to look at the y values. So again, I'm using my pen here. -10, -8. I don't have any graph yet. Here's the first place that I have a graph, which is right at 2, and I actually have a value there. So I'm going to put a dot. And then I've got lots of y values going up, 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 up. And then I have arrowheads, which keep going up and up and up. So my y values start at 2 and go up from there. So in my range, it's going to be y is greater than or equal to 2. It doesn't get a a high boundary because it never stops. The only time you put the y in the middle is if you have a starting point and a stopping point. Then the y goes in the middle. If it's shooting off, then it's just the one inequality. Okay, so let's look at this one for maximum and minimum. Now this one, you can tell the arrows keep going forever and ever and ever, so there's not going to be a maximum. There's no maximum y value. All right, well, let's look at the minimum. Do we have a smallest y value? Yeah, look at your range to figure that out. The smallest y value is a 2, so y equals 2, and it occurs at the point 4, 2, so at x equals 4. So how low it is and then where it occurs. All right, flip the page. Okay, so kind of a weird looking triangle figure, but we can still do a domain and a range. So let's start with domain. We're going to go from the left. The very first x value I get is right here at -10. And then I have some graph, and my last x value is here at -4. Both of these are closed points, so you own both fences. So this is your domain. So x is less than or equal to -4 and greater than or equal to -10. And they're filled in, so both arrows get the bar to show it's equal to. All right, now we're going to do the range. So starting from the bottom, the lowest y value we hit is right here at a 2. And then we have a bunch of graph, and the last y value we hit is here at 7. That's the tallest y value. So my range is between 2 and 7, and it's including the endpoints. So inclusive, so y goes in the middle, less than or equal to 7, greater than or equal to 2. All right, let's look at the maximum. So maximum means there is a tallest point. Well, yeah, on this triangle up here, that's your tallest point. So yes, it has a maximum. And your y value at that point is 7. So y equals 7. And the maximum occurs at the x value that goes with it. X equals -8. That's the tallest point. That's the maximum. Now the minimum. We have a lowest point. It's this one. And at this point, y equals 2. And that 2 occurs at the point x equals -10. So this one had a maximum and a minimum point. All right, last one. We're going to get into a little bit more fancy notation. All right, let's look at domain. Starting from the left, my lowest x value is a -8. It's not included. That's the fence you don't own. Then I have graph, and then it stops at -4 with a filled in point. Then we got a big gap. And then my next x value is at 0. And I have some graph, and it ends at 4. And then we got this weird thing where you've got a filled in point here and an open point there. When you have an open point over a filled in point, the filled in point fills in the open point. Write that on your graph. It fills it in. So in other words, there's no hole there because it's been filled in by the point directly below it. And then these keep going, x values keep going, and the last x value is at an 8. So what I have is 2 different pieces of x value. So I have to have a way to show 2 pieces. And the way you show 2 pieces is using what we call the union symbol, which we've learned recently. Remember, the union symbol looks like a capital U, but with no stem on it. And the union symbol means both together. Just like when we were doing unions of sets, it's both sets put together. This is both domains put together. Okay, so let's start with this left piece. You're gonna have to write a little bit smaller. This has a left and a right, so x goes in the middle. Less than or equal to -4, because it's a filled in point, an included point. Greater than, but not equal to, -8. That one doesn't get a bar because it's an open point. Here we go, put the union symbol in there, in union with, and now we're gonna do the same thing for this bar. Put x in the middle, less than or equal to 8, greater than or equal to 0. And since this got filled in, this is all one bar with no breaks in it. So that's how you do more than one piece. Just do a union symbol. All right, the range gets a little weird on this one because you've got these horizontal lines. So if you look at this piece of the graph, the only y value for that entire piece is a 2. It's a 2 for everything on there. Then there's a gap, and then there's this piece, this little step here, where the y value for that whole step is 4. And then we've got this step where the y value for the whole step is 6. So we actually only have y values 2, 4, and 6 with nothing in between. If you're going to list specific y values with nothing in between, you use roster notation. So here we go. Y is an element of the set containing 2, 4, and 6. And again, this is roster notation. Anytime you see horizontal lines, you need to consider roster notation. Because a horizontal line means all those y values for that whole line are actually the same. All right, let's do maximum and minimum. So we definitely have a highest step, but it's more than 1 point. So how do we handle that? Okay, so my maximum y value is 6, so y equals 6. Now, this one doesn't just have 1 point, it's 6 for the whole step. So to say where it's at, I'm going to need to give the domain of that step. So x goes in the middle, less than or equal to 8, and then just greater than the 4 because it's an open point. So if you have a whole horizontal step there, you got to put the range of values where that maximum occurs. All right, let's do minimum. Lowest value, definitely here with the 2. So y equals 2 and this also occurs in more than 1 point. So we need that step. So x goes in the middle, less than or equal to -4, and greater than, but not equal to, -8. And again, the main thing that you're looking for with this kind of thing is horizontal lines. That's what causes the need to write your location as an inequality instead of just a number. Okay, those are the notes on domain and range.